Good morning, dear children. Now we can study the third chapter, Playing with Numbers. Here we can study divisibility. We know that when we are dividing 12 by 2, how many 2's are there in 12? We know 6 2's are 12 and remainder is 0. Then 13 divided by 2 is equal to 6 remainder 1. And 14 divided by 2 is equal to 7 remainder 0. Here we know when we are dividing 12 and 14, the remainder is 0. So we can say 12 and 14 are exactly divisible by 2. What is that? 12 and 14 are exactly divisible by 2. That is known as the divisibility. That is, when we are dividing, here we can see the remainder is 0. In case of 12 and 14, when we are dividing by 2, the remainder is 0. But when we are dividing 13 by 2, the remainder is 1. So we can say 12 and 14 are exactly divisible by 2, but 13 is not exactly divisible by 2. Here we can go through the multiples of 2. 1 times 2 is equal to 2. 2 times 2 4. 3 times 2 6. 4 times 2 8. 5 times 2 10. 6 times 2 12. 7 times 2 14. 8 times 2 16. 9 times 2 18. 10 times 2 20. We know all these multiples are even numbers. That is, these even numbers are present in 2's table. That is, all even numbers are the multiples of 2. So we can divide each even number by 2. Exactly divide by 2. So 18 divided by 2 is equal to 9 remainder 0. So we know that 18 is present in the multiplication table of 2. Clear for you? So we can say when a number ends with, that is, if a number has 2, 4, 6, 8 or 0 in ones place, we can say that number is divisible by 2 because even numbers ends with 2, 4, 6, 8 or 0. So here 17,262. Here this number ends with 2. So we can say this number is exactly divisible by 2 because it's an even number. How can we understand an even number? If a number ends with 2, 4, 6, 8 or 0, we can say that's an even number. But 17,267. Here this number ends with 7. That means in this number ones place digit is 7. So we can say it's not an even number. So it is not exactly divisible by 2. That means there will be a remainder. In case of 13 divided by 2, the remainder is 1, not 0. So we can say 13 is not exactly divisible by 2. Clear for you? We all are familiar with the terms of division. What is that? Here we know, here will be dividend, this number will be the divisor, quotient will be there and remainder. Example, when we are dividing 3 by 2, we will get 1 as the quotient. That means 1 times 2 is equal to 2. Okay. Then while subtracting, we will get 1. So here the remainder is 1. When we are getting 0 as the remainder, we can say this dividend is exactly divisible by the divisor. That means the remainder should be 0. Clear? Now we can study the divisibility of 3. We have completed the divisibility of 2 just now. Now we can continue the divisibility of 3. Here we can see the multiplication table of 3. 1 3 is 3, 2 3s are 6, 3 3s are 9, 4 3s are 12, 5 3s are 15, 6 3s are 18, 7 3s are 21, 8 3s are 24, 9 3s are 27, 10 3s are 30. So 3, 6, 9, 12. So here we can add the digits of 12. Here 1 plus 2. We are adding the digits of 12. 1 and 2 are the digits of 12. So when we are adding this 1 and 2, the answer is 3. Now we can add 1 plus 5. That is 6. Clear? Then now we can add 1 plus 8. What's the answer? Yeah, that is 9. Clear? So we are getting 3, 6, 9. So again we are adding the digits 2 plus 1. Here the answer is 3. Now 2 plus 4, the answer is 6. Then 2 plus 7, the answer is 9. Then 3 plus 0, answer is 3 itself. So we are getting the sum of digits of each multiple is 3, 6, 9. 3, it may be 3, it may be 6 or it may be 9. Now we can add another number 7566. Now we can add the digits of this number. That is 7 plus 5 plus 6 plus 6. What's the answer? 7 plus 5, 12. 12 plus 6, 18. 18 plus 6, 24. What is the sum of these digits? 2 plus 4 is equal to 6. Clear? So we can divide this number exactly by 3. Clear? How can we find out? We have to add the digits of the number. Then find out the answer. That means the sum of the digits. If the sum of the digits is divisible by 3, then we can say the given number is exactly divisible by 3. Clear? We can check another number 99. We can add 9 plus 9. What's the answer? 9 plus 9 is equal to 18. We can see 18 is present in the multiplication table of 3. So 18 is completely, that means exactly divisible by 3. When we are dividing 18 by 3, the answer is 6, remainder 0. So when we are dividing this 99 by 3, we will get 0 as the remainder. Can we check now? 99 divided by 3. 3 3s are 9. Then subtract 3 times 3 9. Subtract 0. Again 9. 3 3s are 9. Subtraction 0. So we have divided 99 by 3. What is the answer? 33. Remainder 0. So we can say 99 is exactly divisible by 3. Children, do you need one more example? Okay, we can write 8, 8, 8. Now we can add 8 plus 8 plus 8. What is the answer? 8 plus 8 is 16 plus 8 24. We can see 24 in 3's table. 8 3s are 24. So we can check it now. 888 divided by 3. How many 3's are there in 8? We can say 2 3's are there in 8. 2 3's are 6. So subtract next 28. 8 3's are 20. 9 3s are 27. Then subtraction, 8 minus 7, 1. Again 18, write down this 8. So 18. So how many 3s are there in 18? 6 3s are 18. So we know the remainder is 0. 18 minus 18 is equal to 0. Clear? So we can say 3 multiplied by 296. That means in 888 there are 296 threes in 888. Clear for you? So we can say 888 is exactly divisible by 3 because the remainder is 0. How can we check that? We have to add the sum of its digits. So 8 plus 8 plus 8 is equal to 24. 24 is divisible by 3. Clear? We have checked divisibility by 2 and divisibility by 3. Now we can check divisibility by 4. It's very easy. If the last two digits of a number are two zeros, okay, it may be two zeros, or if the number formed by their last two digits are divisible by 4. Example, 724. We know 24 is divisible by 4. 24, when we are dividing 24 by 4, the answer is 6. We know 6 4s are 24. 4. Okay, 4 times 6 equal to 24. Next example, 728. Here 28 is exactly divisible by 4. How many 4s are there in 28? We know 7 4s are 28. That means 7 multiplied by 4 is equal to 28. Clear? So we can go through the multiplication table of 4. 1 4 is 4, 2 4s are 8, 3 4s are 12, 4 4s are 16, 5 4s are 20, 6 4s are 24, 7 4s are 28, 8 4s are 32, 9 4s are 36 and 10 4s are 40. That is, if a number ends with 0 4, 0 8, 1 2, that means 12, 16, 20, 24, 28, 32, 36 or 40, we can say that number is divisible by 4. Example, 1028. We know 28 is here. That means 7 times 4 is equal to 28. So we can say 28 is exactly divisible by 4. We can say that therefore 1028 is exactly divisible by 4. Now we can check that 1028 divided by 4. 2 4s are 8. Subtract 10 minus 8 is equal to 2. Then 2. How many 4s are there in 22? 5 4s are. 5 times 4, 20. Then subtraction, 28. This 8 is here. 7 4s are 28. So we can say it is divisible by 4. Clear? 1028 is exactly divisible by 4 because this number ends with 28. The last two digits, that means ones place and tens place digit. We have to consider ones place and tens place digit of the given number. One more example, 10,424. That is 24. 24 is here in 4th table. 6 times 4 is equal to 24. So we can say 10,424 is exactly divisible by 4. Clear for you? Thank you. If you have any doubt, please contact me.